before in detail. Today I'll be going over voting classifier once again, or in general the voting method. But what I want you to take away from that is how do you in general go through a method in the sklearn documentation, understand it, experiment with it, and finally use it in your projects. So we'll be looking at voting classifier, but with this objective in mind. Okay, so I hope my screen is visible. So can someone tell me what a voting classifier does? We saw this last week as well. So can someone tell me what does a voting classifier do? Any answers? Whatever you know about voting classifier, you can say. No idea about voting classifier?
Sir, it predicts based on the majority votes.
Okay. So any other thing about voting classifier? It predicts based on majority vote. What else do we need? Majority votes of what? Or are there any different settings in it? No idea? Okay. So let's start it this way then. So we are going to deal with the binary classification problem. So I'm going to say the classes that I have are going to be 0 and 1. And I have three models. So I'm going to call it model A, and model B, and model C. Okay, so I have these three models. So these guys are going to be the ones whom I'm going to use to take my vote and so on. Now, in voting classifier, there are basically two types. There is for voting, there is a parameter called voting, which can either be hard voting or soft voting. Now, when it comes to hard voting, what do we mean by that? So I just told this will be a binary classification problem and that I have three models A, B, C. Now, say the setting is, the voting is, in the parameter is set to hard. We write voting equals to hard. This is my first sort of setup. Now this is model A, model B, model C. And these are its predictions. So model A is going to predict, let us say 1, this is going to predict 1, and this is going to predict 0. Now in this case, what should be the answer? I'm not asking why, what do you think is the answer?
1, sir.
1, right? So final prediction equals to 1. So this is what I have. Now what has happened behind the scenes is that we said the voting classifier was made up of three models, and it used all these three models to make predictions. Two of the models, that is A and B, predicted 1. So these two guys predicted 1. Whereas model C predicted 0. So what this ended up giving is, from the final model, let me call the final model as say CLF, final model. I'm just going to name it as voting CLF for now. So for this guy voting CLF, it ran this particular sort of test point and made its prediction from these three models, and two of them, since they gave it as 1, so finally this ends up being the count. So for class 1, there are 2 votes, and for class 0, there is 1 vote. So this is what ended up happening, and now it takes the majority, and since this one happens to be the majority, so the voting CLF ends up predicting prediction equal to 1. Any doubts so far? This I am assuming was fairly straightforward. We had a voting classifier. We had 3 models that were a part of it. The setup was hard voting, and the 3 models made predictions. And based on those predictions, we saw how many votes belong to the different classes. And then we took the majority, and based on that, we got the prediction as 1. Okay, this is the first setup. Now let's go for the second setup, which is when we have probabilities. So here the second setup, this time the kind of vote taken is soft. So once again, let's make use of this. So this time, instead of predicting the class, it is going to predict probabilities. So probability, the probabilities should be for class 0 and class 1. Because it's a binary classification problem, we have 2 classes. So each model is going to give probabilities of your particular test point, that while you are predicting which class will it go to. So let us say for class 0 the probability was 0.44. Then what should be the probability for class 1? Model A has predicted 0.44 for class 0. Then what should be the probability for class 1?
0.56.
0.56. So this is just the straightforward stuff. Any model, if it predicts and it is a binary classification problem, the probability value should be divided between the two. So we'll continue. So the next one, let's say it was 0.38. This is going to be 0.62. And let's say this is 0.53. And this is going to be 0.47. Now in the case of soft voting, what this particular model does is that the first thing it is going to do is it is going to sum up the probabilities. So what will be the sum of these guys? So you just need to add these values. So for class 0, I'm going to sum up 0.44 plus 0.38 plus 0.53. And this value turns out to be, how much is it? Plus 0.38 plus 0.53. This turns out to be 1.35. Then I have to also sum up these 3 guys. So it is 0.56 plus 0.62 plus 0.47. What should be the answer be?
2.05.
How much will it be?
2.05.
It's a 2.05. 0.56 plus 0.62 plus 0.47. It's actually 1.65. So can you cross verify? I think these should be the answers, because when you sum up these probabilities, it becomes 1, this also becomes 1, this also becomes 1. So when I sum up all these values, at the end I should be getting the value 3. Does that make sense? The contribution by each model is 1. So that way when I sum up all the probabilities, total should be 3, which is why, yeah, please go ahead.
No, sir, wrongly I did.
Okay. So because the sum of these three guys happens to be 1.35, this one has to be 3 minus 1.35, which turns out to be 1.65. Okay. So I hope this is clear. Now once we have this value, what voting classifier does next is, it is going to take the argmax of these probabilities. So what does that mean? So it is going to take argmax of 1.35, 1.65. So in this particular case, 1.65 happens to be greater, and this 1.65 is the probability corresponding to class 1. So the final prediction is once again class 1. Okay, so the prediction is 1. Now there is one more point to this. So we have got probabilities from the three models, but what is the probability that the voting classifier gives? That is the ensemble model. So what we call here as voting CLF. What will be the probabilities given by this guy? Any answers, any thoughts about it? So these three guys, the model ABC, they gave their probabilities as seen here for both those classes. What will be the probability given for class 0 and class 1 by this voting CLF? Any answers? What do you think it will be? So we know that the value of probability should be between 0 and 1, and that the probability of class 0 and the probability that the class belonging to class 1, if you sum those two, again it should be equal to 1. So now when we took these values, we got 1.35 and 1.65. One of them is the probability of belonging to class 0, another is that for 1, but we'll have to normalize it. So what that means is this 1.35 divided by 3, 1.65 divided by 3. So this gives us, what is it? 1.35 divided by 3, which happens to be 0.45. The other one has to be 0.5. Okay. So is this clear? So what we did in setup B is we once again had the three models. Only that the setting we have changed for voting went from voting style hard to voting style soft. So this way we got the probabilities for the two classes for the three individual models. Then we summed up the probabilities, and whichever the argument turned out to be maximum. In this case, the comparison was between 1.35 corresponding to class 0 and 1.65 corresponding to class 1. The maximal argument was for class 1, hence the voting classifier predicted it as 1. Since this includes probabilities, the voting classifier also puts forth probabilities, and the value of the probability value that we get for the two classes is just the normalized values of those sums. So we get 0.45 and 0.55. Clear so far? Any doubts? Okay. So now we are going to increase the difficulty a little bit, in the sense that this time we are going to include the idea of weights. Let me copy this thing again. these are known, the final prediction don't know. This one is proof. Okay, we've got some context. So the other one I'm going to say is this time I'm going to have weights. Okay. So once again, we've gone back to the first setup, wherein the kind of voting is, the style of voting is hard voting. And this time we have weights. And these weights correspond to the models that we have. We have 3 models, and this basically dictates how much importance I should give to those 3 models. So let me first take the weights to be equal. I give 1, 1, 1 for all of them. What this is going to mean is, so if model A has predicted 1, so let's do it this way. Here what did we do? We counted how many votes. So we did this, right? This particular part here. So how many votes went for class 1 and 2? We counted it. So likewise we are going to do it here. So from model A, votes for class 1, we have 1 vote from A plus 1 vote from B, and there are no votes from C. Likewise, votes for class 0 is 1 vote from model C. Right? This is when the weights are 1, 1 and 1. However, we are going to make a change to this and let this be the setting 2, wherein we give 3 weights to class 1, 1 to this guy and 2 to this guy. So this means that every vote from model A has to be multiplied by 3. So in my second setup, this 1 vote now becomes 3 into 1, plus the weight of second model is still 1, so it is 1 into 1. And now this guy is 2 into 1. It predicted 0, but yeah, it had 1 vote. So basically now what we have for votes 1 is 3 plus 1 giving 4 votes, and this guy giving 2 votes. So now class 1 has 4 votes, class 0 has 2 votes. Once again, the majority happens to be class 1. So the final prediction is still going to be class 1. Now if I were to change it once more, this is my third setup, wherein instead of this one, let's give 1, 1, and the final guy gets say 3 votes. Now this is going to change up to the case that this guy has 1 vote with 1 weight, this guy also has 1 vote with 1 weight, this guy has, now the weight is 3, so 1 vote from model C. Not necessarily. It's more of, there's no specific theory behind it as such. So for those of you who might see this later, the question is, how do we decide the weight for the 3 models? I would say it is going to depend from situation to situation. Maybe you can see how much of your model is tuned, which one do you want to rely on more, and that way you can set it. Once again, yeah, it'll be a bit like hyperparameters in the sense we don't know beforehand what is good and what is not. It's a bit of an experimentation related. Okay, so just to close this, so this one now has 2 votes for class 1, and because of the weight, there are 3 votes for class 0, and this time the final prediction ends up being class 0. Okay, so this is the advantage of giving in weights. Now, say you have some models which are not performing that great. Maybe they are very simple models, but you still want to have them in your setup. There are some models which are performing very well and you want to primarily rely on those guys. In that case, you could probably go with this. Give a higher weightage to those and lower weightage to the other models. Now things get a little more challenging now when we talk about weighting for the case with probabilities. Anybody any doubts with the weights when it came to the previous setup where the voting style was hard. I think in the last session there were questions. Any questions so far on this? Okay, all right. So now what is going to end up happening is, so once again I'm going to give weight.
Excuse me, sir.
Yeah.
Sir, what is this voting equals to soft?
So voting equals to hard is the first case that we did today, which was when you take the votes and then based on the majority you make a claim. So that is your models ABC. Directly tell, okay, my prediction is class 1 or my prediction is class 0. Simply based on that you
Yes.
take a majority vote and do it. In the voting equal to soft setup, it is like, okay, with 44% probability, I believe it is class 0. With 56% probability, I feel it is class 1. Okay, so
Understood. Okay,
yeah,
sir.
and then you sort of combine, take the argmax and make your prediction. Okay, so it is that way. So coming back to this setup, now voting is soft, and this time I'm going to set weights. So first, if we have 111, the calculation remains the same. You just sum up these three guys as it is, whatever was the value, 0.44 plus 0.38 plus 0.53, so it's 1.35. So you get your value 1.35 here, likewise 1.65 here. You take the argmax and you proceed. Now the only difference is, now if I change the weights, so let me say the new weights are 2 for this guy, 1 for this guy and 1 for this guy. So if this happens to be my new setup, now, and of course you should recollect the weights corresponding to the model. So model A, model B, model C. So now whatever probability I have from model A, I need to multiply it by 2. So it becomes 0.44 into 2 and 0.56 into 2. This will remain 0.38, this will remain 0.62, this will be 0.53, this will be 0.47. Okay. So this is just, I'm writing the values from above, but this time I've multiplied the weight. Now when I add this, choose to add this, so what is 0.44 into 2? It is 0.88 plus 0.38 plus 0.53, which turns out to be 0.88 plus 0.38 plus 0.53. It is 1.79. Now, without calculating manually, can someone tell me what the probability here should be? So if I sum up the values, what will I end up getting? I want the answer without calculating.
1.21.
Can you tell me why it is 1.21?
Sir, totally it has to be 3, sir.
You are almost correct, but what will be the difference here? Since I'm asking the question, there should be some change as compared to before. What will be the difference? Anybody else? Any answers? Okay. So the difference that is going to be is, this time we have weights. So last time,
Weight is 2 plus 1 plus 1, 4. That's
correct.
all.
So that is where I was getting to.
So here, when we calculating the probability regarding to 0, it's going to 1.84 rather than 1.79.
0.88 plus 0.38 plus 0.53. 1.79, right? Can someone else confirm?
Oh, okay, sorry, sir. I write 1.58 instead of 1.53. Oh, sorry,
Okay.
0.53.
Okay, yeah, no issues. So I think Hema said that it would be 1.21, which was almost right, except that this time since our total weights, so it is this here, is 2 plus 1 plus 1. The total one will be 4, which is why it is 4 minus 1.79 giving 2.21. So this should already tell you what the probability given by, of course, now we are going to do an argmax of 1.79, 2.21. Since 2.21 is more, the prediction is going to be class 1. So final thread is equal to class 1. But interestingly, what is the probability given by voting classifier? So we have voting CLF. What are the two probabilities? What should it be? I don't need the exact value, but what should I calculate?
So 1.79 divided by 4.
Perfect. So this time, last time, if you go back here, we had 1.35, 1.65. We said that the total probability value was 3. So dividing by it gave us 0.45 and 0.55. Whereas this time, that because of the weights, the total weight is 4. So it is 1.79 by 4 and 2.21 by 4. So this turns out to be 0.4475. And 1 minus whatever this value is 0.525. I've done it right. So this will be your final probabilities, and as you can see, again, this is the corresponding to the maximal class with the final prediction being 1. Okay, is that clear? Any doubts? The multi-class classification with soft coding. Sure, we can do that as well. I'll probably do it with code. I'll briefly tell you how it goes. If you don't get it, then we'll do the exercise to code it. So far, is this one clear? Whatever we just covered. Anybody any doubts?
Sir,
Yeah.
sir, even if we don't normalize, it's going to be the same prediction, no, sir?
The prediction is going to be the same. It is just what will be the probability by the voting classes, because we cannot say 1.79 and 2.21, right?
Okay, sir. Okay, sir.
So
Got
just
it.
for that we normalize. Otherwise, it has to be the same, right?
Okay, sir.
Yeah. So here now the same thing. If instead of this 211, say I did something like, let's see which one is lower. Let's try and get the prediction to be 0 this time. Instead of 211, where is the same values? Last time, what did we have as the final prediction? We had 0.45 and 0.55. This time it is slightly reduced. So let us give the weights to be 1, 1 and 3. Okay. Let me actually do this next. This time I'm saying the weights that I want to give are 1, 1 and 3. That is, this guy is going to be multiplied by just 1. This guy is also going to be multiplied by 1. This guy is going to be multiplied by 3. So 1, 1, 3. So once again, let me do the calculation for one side. We have 0.44 plus 0.38 plus 0.533, which is 1.59. It is 1.59. And the total comes out to be 0.38 plus 0.44. So we get 2.41. So what is the value on the other side? How much will it be? Without calculating, we just did this exercise.
1.59.
Is it 1.59?
Sorry, 3, 4, 5 or -5.
Yeah, it is 2.59, right? Because this time
Yes.
my weights are 1, 1 and 3. So unfortunately, this also has not been sufficient. But if I were to, the arc max is still 1 because 2.59 being greater than 2.41. But if I were to divide, I would get the probabilities as 0.482 and 0.518. Hope I'm right. 0.4. Yeah, it is 0.518. So previously it was 0.44 and 0.55. Now it has changed to 0.48 and 0.518 based on our changing of the weights. Is this operation clear? We did two things. We first saw voting with hard, voting with soft, and then we saw what happens when weights are involved. Okay. Any doubts in what we discussed today? All right. So in that case, let's next go to okay. I hope my screen is visible. As I said at the beginning, today the entire objective of this activity was to see how we can use the documentation, take some simple example, and try and understand how the model works, experiment with it, and finally get to use it better. So this was voting classifier. So there were two things we focused on. The first was voting style hard and soft. So if it is hard, the predicted labels for majority rule voting. So that is what we saw. If the more the votes that went to a particular class, that was being predicted. Else, if soft, predicts the class label based on the argmax of the sum of the predicted probabilities. So that is what we did. We then summed up the probability values and took the maximum argument. Coming to weights, it is a sequence of values where the shape is number of classifiers. So there is a weight assigned to each classifier. By default, we can think of each of them being like 1. So otherwise, it just ends up whatever value is there, it ends up weighting. So either it weights the votes directly in the case of hard voting, or in the case of class probabilities, it just multiplies. Is that okay? Is this clear? Any doubts with voting classifier? All right. So in this case, let's just continue on this with the data set. So this is where you can experiment with things. I'm going to continue using yes, Avinash.
Yeah, so I just wanted to check if my understanding is correct. I was getting this thought. The
Yeah,
difference between hard style and soft style is just the threshold we are setting for a
correct.
classification, right?
Correct. You can think of it like that.
Yeah.
Because see, it is something you'll see later when you do deep learning. There are these things called activation functions. If you've not seen,
Mm-hmm.
so depending on the function at hand, right? So if I were to tell if your value is below 0.5, you make it 0, and above 0.5, you make it 1.
Right.
Now, if the probability of the model, so your model is asked to predict for a point, and if it predicted something like 0.99 towards 0.01 for one class and 0.99 for the other class, we are kind of okay with it. But if it ended up predicting something like 0.49 for class 0 and 0.51 for class 1, then if we were to simply say it as 0 or 1, it is a bit harsh. So,
Right.
which is why, in case our model is generally well trained, then it might be a better approach to go with this probabilistic sense where our sort of putting things in class 0 or class 1 is not that harsh.
Got it, got it. And if we keep the threshold of each models same, in that case, this hard and soft style will give us a similar result. similar predict.
Sorry, could you please repeat?
If I have a 3 model A, B, C,
Yeah.
I choose to keep the threshold for all 3 model same. Let's assume 0.40 for threshold for model A, 0.4
Yeah.
for B, and 0.4 for C.
Okay.
Then either I choose a soft style or I choose a hard style. I will get a same prediction.
Yeah,
This
but then your models, the way they are working is they have their own way of calculating probabilities, right?
is right.
So the probability of the model is what is taken into account. That will actually will break it down here.
Okay, okay, got it, sir. Thank you.
So let me first directly do that part. I think last time I presented with an example, so I'll start with directly take that up. So this is what we had discussed last time. So we've done some imports. Then we have 3 models called classifier 1, classifier 2, classifier 3, logistic regression, random forest, Gaussian naive Bayes. And we have these many points, which are our 6 points, and their 6 labels. Then there is a test point that I've created called -2, 1. So let me rename this guy as vote CLF. Okay, so we've called it like this. Let's first go with hard one. Okay, so this is what I've got as my predictions. Let us look at the individual models as well. So this part is clear, right? So the training data itself, I had 6 points. I've predicted on the training data itself, and it has given me 111,000, while the actual labels are 101,000. So there is one misclassification, the second point. Now let us sort of break it down as to why this has happened. Is the premise clear? Any doubts with what is happening? Okay, all right. So with that setup, let's see what these individual models are CLF 1, 2, and 3 did. So let me call CLF1 dot fit x comma y, CLF1 dot predict x. Okay, so this guy predicted 011,000. CLF2 dot fit. Copy paste. So let's see what the second guy did. It predicted 101,000, and this guy predicted 111,000. So as you can see, for the first data point, there is 1 vote for 0 and 2 votes for 1. So your final prediction ended up being 1. Now for the second point, 1 vote was for 1. Actually 2 votes was for 1 and 1 vote was for 0. So the majority is once again 1. So it predicted 1. The third point, all of them predict 1. So it is 1. And the remaining 3 points also, everybody predicts the same thing. So it happens to be that. So now even though the second one was 0, our model predicted 1 because it went by majority. So if you notice in this particular case, this second model that is there is actually performing perfectly. Every single prediction it has given correct. But because we are using voting classifier where all the votes are considered, even though this model has done better, our final predictions are these. Is that okay? So hard voting basic setup is clear, right? Now if I were to introduce weights, now I want to make sure that this second value is 0. Yeah, is there a question?
If we do the same thing with soft, what will happen?
Yeah, we'll come to that.
Okay.
Yeah, we'll be doing all this.
Okay, thank you.
Any other questions? Okay. So I'm going to set weights now. And if I want the second prediction to be 0, I'm not saying I'm correcting this or something. I just want the second prediction to be 0. What value should I put in? What are the weights that I should give? Any thoughts? There are many weights that I can give. But what should I do? So here so far in the first setup, 2 guys are predicting 1, 1 guy is predicting 0. I want the second one to come as 0, so I need the majority to be 0. So what is one combination that I can give here? Yeah, please go ahead.
Yeah,
No,
if
higher than 1 and 3. Weights higher
Yeah,
than
higher than 1 and 3. Okay, just give me one combination, anybody.
1 to 1.
1, 2, 1. So now I'll have 1 vote each from 1 and 3, 2 votes from this guy. So here there is actually a dilemma, but let me run this. So now it has given 0. And these guys, of course, will remain the same. Their predictions will not change. But the voting classifier now has shifted to 0. Because there is 2 votes from this guy, whose prediction is 0. 1 vote each from 1 and 3. Now the point is that there are 2 votes in total when I sum up classifier 1 and 3 for class 1 and 2 votes for class 0. So there is no majority. There is actually a tie. But the reason it went for 0 has to do with how sklearn works. So in sklearn, at least in the current implementation, it always picks the class with the lower index. So that is not something that is, necessarily that it has to be that way. There is nothing like that. So which is why in general, when we take votes also, it is good if we have an odd setup. Either, go with 3 models where the weight is 1 each. Because total number of votes, we want it to be odd so that there is no tie. So that way I can give anything. And if it was not already 0, in this it would have become 0 because now there are 3 votes from this guy. So that is equivalent to saying 3 guys have said 0, whereas here 1 plus 1, only 2 guys said 1. So which is why your final prediction is 0. Okay. So that was hard voting with weights that are there. With me so far? Whatever we did on pen and paper, similar thing we are doing through code now. So this is how easy it is to actually understand and break down a model, which is what ideally you have to do with most models that you work with. Understand why things are behaving the way they are. Okay, so next let's move to, yeah, please go ahead.
Yes, sir, I understood the concept of giving the weightage,
Yeah.
but I was more concerned about how we are deciding this weightage. If I have the result of individual models at my hand, I can take a reference from the accuracy of individual model and
Correct.
give higher weightage to the model which have a higher accuracy. But how we decide it practically?
Yeah,
I
so
can't.
in most cases, it will almost always be that one of the models in your voting classifier will end up performing better than the others. Will end up performing better than the entire setup. Like it will perform better than the ensemble. As we
Right.
saw in this case also. This guy predicted the exact one, whereas the other 2 guys didn't. But because of majority setup, even if this guy was correct, we end up getting incorrect. Now the point is that you will not always have proper test data with you. So in practice, you do not know that this is what my data is going to be. You can run your tests and you have got some result. Now you have one model that is performing well, but at the same time, you want to sort of try out how different combinations of models, like some models might do well with certain parts of the data. Other models might do well with other parts of the data. So you don't always know that the new data that you get is going to be suitable for one model or the other. So in such cases, it might be a safer approach to go with this ensemble setup. And coming to weights, like I said, you can tend to give, if you feel one model is doing well for the most part, so you can give it a high weightage, but you can still keep some low weights and use this as sort of an analysis method, something like that. Is that okay? Yes, please go ahead.
Sir, I have one small doubt, sir, apart from this, sir.
Yeah. Is it related to this method, the voting classifier?
Yes, sir. When we compare this regression and classification. Generally we don't fit on this training part of the data, right?
When we are training, we are going to fit on the training part, and on
Yes.
the test we do the prediction.
But in case of this classifier, we are fitting with X and Y and predicting on Y. So,
Yeah, so here in this particular example, we have fit with X and Y. I have not separated out a train and test. So this is a dummy example. And here, whatever is there on the training data, on that itself, I'm simply predicting just to show. In practice, I can, I can just I can change this to X test. And everywhere we can change it to X test. So in practice, you train on your training data and then predict on your test data, on your unseen data, so to speak. We could have done this, but I just wanted to have more points so as to show an example of how the values change. So this is not an indication of how it is done with data sets in general. That idea I hope is clear.
I wanted to understand, sir, once we have fitted on X and we are trying to predict on this X again, so
Yeah.
will not this model will copy from this?
Correct. It has to overfit. It will sort of memorize. All those problems happen, which is why we don't rely on training error, right? We always look at test error. So
while understanding this, can we say that this prediction is going to be similar on test also?
No. So whatever the prediction, whatever score it gives on training data need not be what it does on test data. It might perform very poorly on test data. So whatever we are seeing today, you should not take it into account. This is only for like learning purposes.
For sake of comparing, understanding this, right?
Yeah.
The score might be poor.
Because here, if you see, even though I'm doing it on training data, this model, which is the logistic regression model, actually made a mistake. It has, instead of the actual labels are 101,000, but it has predicted 011,000. So it has gotten two predictions wrong, even though it is the training data. So
even if after fitting that, sir, even after that, it is making mistake.
Yeah, correct. Because there are limitations, right? So here, if you see, this will be a slight digression, but the thing is, all these 3 points are, having both the things negative. So it's a third quadrant point, whereas these 3 guys are in the second quadrant, I think, or first quadrant. These are all positive points. But if you see the labels, for 2 of them I've given one class, and for the remaining 3 I've given the other class, which means these are not linearly separable. At least, yeah, this will probably not be linearly separable. -1 will be here, -2 -1 will be here, and this will not be separable by a line that easily. So which is why some simple models that are there, like logistic regression, is somewhat a simple model. Now it cannot predict even on the training data perfectly, because it has no way of finding a line that separates the two. Is that okay? Any doubts in this? Okay, so let me, I'll continue on this digression a bit, because this is an important thing to understand, not from an MLP point of view, but from a general ML point of view, your MLT, or if you're going to write your exams and all. You should know what models do, like do they fit a line? Like perceptron needs data to be linearly separable. That is the case with SVM. But there are ways to work with it even if it is not. Now, if I simply change this class to 1, now you can see this becomes linearly separable. All the negative points have one class, all the positive points have the other class. So let me run this. And now if I do it on this again, so you can see logistic regression model has done it perfectly. Okay. So that was the case. I hope it is clear now. Why even if the training data is what the model is predicting on again, why is it doing incorrectly is for this reason. The data itself, the data and label, the model might not be suitable for it. Okay, coming back to our task at hand. Any other questions? Okay, let's go to the other voting setup. So I've come to soft voting. This time also it predicts 111,000. Of course, the remaining predictions will be the same. But what is interesting for us is going to be the probabilities. I'm going to say vote CLF dot predict proba x. So now I've got 6 values, and we'll kind of do the same for all these 3 models. Okay. So now we know that the model has misclassified the second point, which is this guy. If you look at the probability, it has said 0.37, 0.379 to 0.62. If we come to these individual guys, so this guy said 0.43, 0.56, this one said 0.64, 0.36, this one said 0.058 to 0.94. So let's actually just sum up those values. So we have 0.439 plus 0.64. I'm taking the probabilities for the second point. So this matrix is for the 6 points. What is the probability it belongs to class 0? What is the probability it belongs to class 1 for all the 6 points? Likewise, the 3 models. The final one is 0.058. If I sum these guys up, I got 1.137. So what will be my other value? Point 0.56, 0.36, and 0.94. Firstly, is it clear what I'm doing? Any questions on this? Okay. So roughly, this is 1.137, this is 1.86, and ideally, if I take the full values, it should sum up to 3 because there are 3 models, each of them contributing towards a probability of 1. And now, if I divide this by 3, because that's what we did, right? So divide by 3, divide this guy also by 3. We get 0.34 and 0.62, 0.38 and 0.62, which is what is there here. So 0.379 and 0.62. So is this clear? This is what we did in the hand calculation, right? We took the individual predictions for the all the 3 models. We saw the specific probability values for 0.2. We averaged out based on the weights. In this case, the weight was 1. So we just divided it by 3 for the 3 models. And that ended up being the probability of this second point. Now let's again crank it up by adding weights. So our second model is the one that was giving us the good one, right? So this guy said 0.64, whereas these 2 guys said 0.43 and 0.058. So the second model should have a higher weight. I'll increase it to 3. So this might not solve the problem, but we'll see how the probability changes. For now, remember these values. Let me add it here. Where equal weights, we had this one. This was our value. So now we have a new set of weights, 131. Now I'm going to do predict proba. Now it has increased with 131. So can you see that the probability has increased? So it has increased for class 0. So this way, if I keep increasing, let me go with something like 5 this time. Okay, now you can see it has fully changed. It has even gone to 0.52 with 151. The values that we have are 0.52, and let's actually just verify. So these models, the CLF 1, 2, 3, the individual model predictions don't change at all. They are the same. It is just that we are now weighting it. We are multiplying it with some weight. So let's do that. These were our original values, right? So 0.439, 0.64, 0.058. That is 0.439 for CLF1, 0.64 for CLF2, and 0.058 for CLF3. These three values itself, I am now going to multiply by their weights. I'm going to say multiply with 1 for this guy, multiply with 5 for the second model, and multiply with 1 again for the third model. And then what should I divide with now?
7.
7, right? So I divided it and I get 0.5281, which is nothing but what we have, 0.52, 0.528. The fourth digit, of course, it is a matter of how much accuracy I take, but you can see the value. Same
Sir,
thing.
why we divided by 7, sir?
So dividing by 7, I told previously also, right? So these are because of the weights. So the first time we did it, you have this model giving you 0.43 probability for class 0, 0.56 probability for class 1. So in total, the probability that it gives is 1, right? 0.43 plus 0.56. Model 2 gives 0.64 plus 0.36. Once again, it is 1 when you sum it up. 0.058 plus 0.941. Once again, the sum is 1. So for a given point, in the base case, when there were no weights, all of them gave 1, 1, 1. So a total of 3 was used, which is why in the first case we divided by 3. Now, since we have given weights 1, 5, and 1, the same probabilities that were there, we are now multiplying it, which is what we did here. So we multiplied these probabilities by their weights, which is why the contribution given by each model also now increases. Now the first model and third model, the sum of probabilities by them will remain 1. Whereas the sum of the probabilities by this model 2, because we are multiplying by the weight 5, it is going to end up being 5. So which is why 1 plus 5 plus 1, I have to divide by 7. Is that okay?
Okay, sir.
Alright, so let me just finish up the calculation for this as well. So this was for class 1. Class 0 is what we have above. So if one was 0.52, the other one should be around 0.48. So 0.471, which is what we have here. Okay. So any questions on what we did today? Anybody, any questions? Now you see, right? So it was actually this simple to understand the model. So in depth, why it has made a prediction. So we made use of this predict prober to understand what is the probability it has given. So let's actually see for this test point as well. I've not really given it any label, but yeah, it has predicted 0. Let's see the probabilities. Okay, so this model gave 0.99, this gave 0.76, this one gave 0.73. And our voting classifier, it took the weights into account and gave the value 0.79. So let me actually just change it to 111, so it will be a simpler calculation. So 0.73 plus 0.76 plus 0.99. 0.73 plus 0.76 plus 0.99. And divide by 3. So 0.826. So if we took the decimal places accurately, we'll end up getting this value. Is that clear? Anybody, any questions with how voting classifier works? All right. So this is what was mentioned in the documentation as well. We had voting, we had weights, and then we can see things like estimators, and then the other things we did were things like this predict, proba, and so on. We made use of this, right? So this gave us the values. So most of what you need will be in the documentation, and it is as simple as this to explore a model. Okay. So that was for this one, and I'll show the AdaBoost model. This is one thing that was remaining from this week.
Before going that, can we
Yeah.
turn it to soft and then see what happens? I'm still not getting what is the difference between hard and soft.
Oh, we actually just did it for soft now, right? See, the voting was soft.
Oh, is it?
Yeah, that is what we did in the second part. The entire discussion on probability and everything was when the voting is set to soft.
Okay. So what is the real difference? I don't see it. What is the difference? It is still
So in the case,
right?
yeah, were you there in the first part of the session?
No, first 20-25 minutes I was not there. I joined a bit late.
Okay, so I'll tell this briefly now, but you can revisit there. We did the same calculations by hand as well. So when you have voting set to hard, each model does not give probability, but rather just says my vote is either class 1 or class 0. And I take the majority, and based on that, my final model predicts. Is that okay?
Yeah.
Now when I set it to soft, I'm not asking you whether your vote is towards class 1 or class 0. Instead, I'm asking you for the probability. Now, you can give me different values. Like for example, this one set 0.72. This one set 0.76. This one set 0.73, 0.76, and 0.99.
Okay, thank you.
Now I sum up these three values.
I understand. Yeah.
And for the other three also I sum up the values. I take the argmax, and based on that I predict.
You predict after based on the probability you calculate argmax, then you do the
Correct.
final decision.
So now, for example, this is separate example. So if my first model had predicted 0.54, second guy say 0.46, and third model, let us say 0. Let me make it 5.1. So this is from model ABC. The sum of this will be 0.51 plus 0.46 plus 0.6, which is whatever value, but in hard voting, wait, this is probably not sufficient for that. I'm trying to get to a setup where the individual models will, if you take it, it might say the other class, whereas, okay, I think I can take this. 0.7. Let's take this. 0.51 or 0.52 or something, and let the final one be 0.01. For class A, class 0. For class 1, this is 0.49, this is 0.48, and this is 0. What will the value be? 99. Am I right? Okay. So now if I take hard voting, the first guy will predict 1. The second guy will predict 1. The third guy will predict 0. So is that okay? Is this correct?
Yeah.
I'll write it here. So hard voting first guy predicted 1, second guy predicted 1, third guy predicted 0. So majority equal to 1 because it has 2 votes. Now if I do soft voting,
Sir, are we predicting it because the value there in class 0 is more? That is why.
yeah. In hard voting, that is what we do. If the probability towards class 0 is more than class 1, we predict class 0. That is hard voting. Now in the case of soft voting, we are not that ruthless. We are going to sum up the probabilities. So the model 1 said 0.51 plus the model 2 said 0.52 plus the model 3 said 0.01. What does this become? This becomes 1.04. I hope I'm right. So now if I take for the other class, it is 0.49 plus 0.48 plus 0.99, and this value should inevitably be 1.96. Oh, this I've done wrong, right? So this is class 0. Class 0, class
Yeah,
0, class 1. So majority is class 0 with 2 votes. And now in the case of soft voting, this was for class 0 and this is for class 1. Now because 1.96 is greater, so 1.96 is greater than 1.04, so you take the argmax and it is the final prediction is 1. Is that okay?
Thank you.
This example made sense, right? I know I wrote it a bit haphazardly using this markdown. Did this cause a doubt to anybody? Okay. So all we showed is that how the setting of voting being hard or soft is going to change the result. Because when the votes are 0.51 and 0.49, it is actually very harsh. It is very harsh to the model because even though it is not very sure which class it belongs to, we are forcing it to tell one of the classes. Whereas when we go for a soft voting setup that is based on probabilities, it can now say how much it believes that it belongs to a particular class. And then when we sum up, we found that there is a higher chance it will go to the other class. Okay, so this is how it works. I hope that cleared it. I wanted to briefly show AdaBoost. Let me do that. Okay, this is not. Okay. So now we come to the AdaBoost model. So this is actually our code from the last time, in the same notebook. So let me just run things from the beginning. So this is that rainfall data set we have been working with all the while. So we split it and then let's get to the AdaBoost model directly. I think last time I briefly showed the AdaBoost model with the score, that it gives a pretty high score is what we ended up seeing. So where is AdaBoost? Okay, it's here. Okay, so we train an AdaBoost classifier. This is the same data set as last time. It was split into X-train and Y-train. And finally we fit it. And the reason I wanted to show is the parameters that are there. Here one is estimator. So in estimator, what is the base estimator you want? So here you can pass in your decision tree and you can give all kind of settings that you want. So you can change the max depth, you can change the minimum samples leaf, minimum sample split, and so on. And then is the number of estimators. By default, there will be 50 estimators. Because what does a boosting model do? It first takes a base model, your very simple decision tree. It trains the data set using that model. And based on those predictions, it gives weights. If your model has predicted some samples poorly, that is incorrectly, it gives higher weightage to that. That is, next time the model is going to focus on those points which it classified incorrectly. And this way it keeps on sequentially updating whatever it has learned. And in the end, we might take something like an average and give our final prediction. So then it has a learning rate. So this is how much contribution should come from each classifier is what it is telling. By default, it is 1 for everything. And then there is a random state which happens based on, why would it need a random state here? Okay, I'm actually not sure what is the random state it makes use of in the case of AdaBoost classifier. It could also come from the decision tree part that is there. Yeah, this is random state given at each estimator. So this is corresponding to the random state that goes within this. And coming to the attributes, you can see the base estimator, you can see what are the individual estimators, the weights that are there, and finally the errors. So these are your important ones, which is what I had run here. So you have, first you fit your model, and then you can see the first estimator, which is the decision tree with depth equal to 1. So here if I were to pass estimator equal to decision tree classifier with max depth equal to say 3. Okay, I suppose it's from an import from sklearn.tree import decision tree classifier. Okay, now it has made use of decision tree, but this time with max depth equal to 3. So now my base estimator changes to decision tree with max depth equal to 3. Then I can see my individual estimators. So because there were 50, there are actually 50 in this particular list. So it has trained 50 different decision tree models, updating every time whatever incorrect predictions were made. Now these are nothing but the weights. So this is 1 for everything. And this is the errors by each of the model. So this is what, these are the errors that each of the models made. And finally, these things end up being averaged, and these are the values that we get. So AdaBoost model also has feature importances that it gives. And we can see in the data set that we had. So these were its importances. Unfortunately, it has given 0.11 for ID. So practically, you will have deleted that feature and then run it. Other important features are, okay, once again, day, which should not have been very relevant. But we see something like cloud, which is 0.10, sunshine 0.10. And if this model were to perform well, let's see the score. Okay, it is 0.81. Let's go back to the initial one and see if the score is higher. Let me say max depth back to 1. This is nothing but your basic model. You can see your max depth is now 1. It is already trained, so let me get the score. Feature importance as well. Okay, from 0.81 it is 0.85 now. And if you see the feature importance, there is 0.18 to humidity, 0.14 to cloud, and so on. Last time we saw this feature importance with other methods as well. We saw a decision tree and random forest and all that. You can compare these things. So it's not a guarantee that you're always going to get something very interpretable. But that is the starting point. From there, you can go on delving deeper into what these predictions mean, why has your model predicted it this way, and what analysis you can get from it. So was this okay? Simple intro to AdaBoost. Is it clear? Okay, all right.
Yes, sir.
So now this will be, so this session is the last session where you are going to be looking at these classification and regression models. I think the subsequent week has to do a bit with the clustering algorithms. Of course, you'll see MLP regressor and classifier. But in general, the broad collection of these algorithms are done. So now once again, I'll ask the same question. Have any of you all worked on this particular data set, on the rainfall prediction data set? Anybody? Show of hands if you have worked on this particular data set. Okay. How many of you here have the MLP project this term? A show of hands. None of you all? Okay. So in that case, any one of you can volunteer to share your screen and start working on this data set. But all you have to do is you are just going to be presenting your screen, and collectively our entire group, including myself, will be telling you what to code and what we are going to be doing. So if any of you are willing to volunteer and do it, you can do it. If not, we will be closing the session here.
Shall I do, sir? You will be helping, right, sir?
Yeah. Through the entire time, your only work will be to present your screen and type what the rest of us will tell you. Of course, you'll be having your own inputs, but you absolutely don't have to worry about whether it's right or wrong. So if you are ready, please feel free to share your screen, go to the Kaggle page, this particular competition. Yeah, your screen is visible. So those of you who have not tried Kaggle so far, I urge you to try Kaggle at least maybe in the term break. It will make your project work very smooth. You'll need to sign in. Have you made an account?
Yeah, I have made it. Let me log in then.
Yeah.
Right.
Okay. So can you go to competitions on the left tab? Can you click on playground competitions? So this should be there, the right arrow that is there. Yeah, the right arrow next to community. So there is all competitions featured, getting started research community. There you can click the right arrow. Yeah, so click on playground. The first one. You can go to data. Yeah, join competition first. You can scroll down and click on I understand and accept. You can now go to code.
Join competition.
The join competition button will be there on top. If not, even when you go to something like data and all, it prompts you to join the competition first. So as you navigate the platform, you'll figure it.
Okay.
So can you click on code now? Code. So here I will not be introducing Kaggle now, but we'll run through a notebook. Can you click on plus new notebook? Okay, so now this is our notebook, and once it loads, the data set will already be added. 1 second, you can wait, let it load. And we can start working on the data set. Okay. So can you run the first cell? You can also click on the cell and then press Control Enter. Okay. So now you can click down on the code button first. Okay. Now in the first cell, when you ran, it is the default cell block that is there in Kaggle. What it has done is it has brought in for the 3 data sets, it has brought into the session. So now we can read those particular data sets. So can someone tell me what is the code to read the data set? If you know it, you can write it on your own as well.
Is it correct? PD.3.
Perfect. Yeah. So now the path of the training data. So for that, you can one way is you can check on the right side tab. There is something called competitions, right? Can you click on the drop down right side? Right. Yeah. There is a binary prediction with rainfall. Can you click on top under competitions? Yeah. So there is a train.csv. So you can click on that path icon. There is train.csv, right? Scroll down. That is test on the copy file path. Okay, you can close that tab. The test.csv tab. Yeah. So now put quotes and write this particular path. And on the front, you can assign it to something. So you can assign something like test is equal to pd.readcsv. Same thing you do with train. The same thing you do with train. You will get the path in a similar way. And run it. Okay, you can run the cell. Control Enter. You can hold Control and press Enter. Okay. So now press another code cell. As you can see, the number there has changed, I think, to 3 now. It just shows how many cells have been run, something like that. Okay, so what should we do next? We have read the data set. What would be the first thing that you're going to do?
Visualize the data sets.
Okay, you want to see the data set. So above this cell, scroll above this cell and there's a markdown option should pop up. No, just above that cell. Go down, the active cell that you had. Scroll down a little. Yeah, so above that there is a markdown symbol. Can you see? No,
Yeah.
Come down. Yeah, markdown. Click on the markdown cell. Okay, now we can type. What do you want to type? So the task that we wanted to do was we wanted to observe the data sets. So you can type, let us observe the first few rows of the data set. Yeah, anything, some comment like that. You guys, the rest of you will roughly get the idea, right? So we are saying what we are going to do. We are going to observe the first few rows of the data set. Alternatively, you can even add it as a comment in your code cell. Okay. So now come down below to the code cell. Okay. And how am I going to observe the first few rows? What is the code snippet for?
Train.head.
Yeah. So can you run that train.head?
Brackets.
Sir, we can use sample also here, sir.
You want, what do you mean? The sample submission.
No, sir. Instead of head, train.sample also we can use.
Whatever suits your fancy. If you want to observe whatever rows, like in head, you can pass 10 as an argument if you want. So anything to see the first few rows. This is just a rough, this one. Now When you use dot sample, it is going to give you a few rows of the data set. So whatever particular, you might give some access, you might say how many points you want. Based on that, it will give you some values. Head is something that is used in general.
Okay, sir.
So now this one gave you just one row. So head is what we use commonly. So you can go back to just train.head for now. Okay, and can you press that button on the, for one you can click on the cookies part, you can close it. You can use something like okay, got it. And then there is an arrow mark there next to the table of contents. Okay. So now click on markdown cell. So this is the activity we did previously as well. So now what are your findings? So everybody, what do you see from this train.head? What do you get? It's the same thing we did. You can just recollect and mention whatever is there. What are the comments based on these first 5 rows?
All are numerical data.
Perfect. So we can start with that. You can put an hyphen and then give a space and write all features are numerical. Whatever. So I just want you all to get the overall sentiment of what we are trying to convey. So the wordings I will leave it to you. Okay, so this you can improve with time. So what is the other point? What else do we see? Do we see nothing else?
The rainfall depend on the cloud.
The rainfall dependent on the cloud. How do we know it from this particular one?
Like the value of cloud which we are getting are high, and suppose you're 45, we are getting 0. So because it's
But
less.
then 47 is 1.
Yeah.
And we are only seeing 5 rows here. Yeah, I see 1 in the chat. So that is another observation. We observe that the target variable is rainfall, and this will be a binary classification problem. So by the way, this for the remaining 10-15 minutes we'll just be doing this together. We are going to try to code and prepare a notebook. So if you guys are already comfortable with this and familiar with this, you can feel free to drop off. I will not be covering anything else today. The only task will be how to prepare a good end-to-end notebook. Perfect. There is another one on the chat. So the second point right now we cannot comment on it. You can keep it to the Kaggle screen. I will read out whatever comes up. Okay. So the second point we cannot say right now that rainfall is dependent on cloud because we are not sure of it, right?
Yeah.
So we can say that the target variable is rainfall, and this is a binary classification problem. So for now this is fine. If you all have more points, you can always speak up and add. If not, what is the next code snippet that you would want to run? What will you do? We have done data.head. We have observed the first few rows. What do we want to do next? No answers? Okay, we have data.describe. Fine, data.describe is something you can run. So here what will it be? Train.describe. Okay, so what will be the comment for this? I want you to add a comment above this. Instead of markdown, it's in the code cell itself. In the code cell itself, you can run. No, in the same code cell. Yeah, wherever you have run train.describe, you can add a line above this. That is, you can go to the starting of it and press enter. Yeah, in the above line, write a comment. A comment you can put yes. So what are we doing here? What does train.describe do?
Find the outliers. Is there any outliers?
Okay, so can we say in general it gives the summary statistics, it gives information about different statistical measures.
Yes, sir.
Yeah. So ideally here you can put something like, no, now you can give it. You can just write give summary or summary statistics of different features, something like that. Okay, so that is fine. You have run the cell. Now below this, you can go to the markdown. And what are your observations? What do we see from this? I want at least 1 or 2 points if we are to move ahead. In train.describe, what do we see? Any comments based on these values? One of the points that we have written earlier is actually relevant here as well. So what is that point?
So
What
the
is that?
dew point, so the dew point in the humidity, like the first few rows seems to be like here. This one, aren't they seeming to be same?
Okay, but what is the first row saying? What is the first row?
Okay, it's the count, I believe. Yeah.
Yeah, so the count is going to be same for all of them. Anything else that we can see? It doesn't have to be very specific. Broadly, what do you see?
The dew point and the humidity look like more or less picture. Doesn't
Are you saying dew point and humidity feel like they are similar? Is that what you said?
yes.
Okay. Is there another sort of statistical measure that we can use to identify how similar two features are? What it would be?
The range.
Range is okay, but there is one thing that we almost always use to say, okay, this feature and this feature are either related or not related.
Correlation.
Perfect. So that is something we can discover there. Here at the end of the day, we still have 5 values. We can roughly get an intuition, but we cannot directly say that that this is specifically the value that it takes, right? But one other point I want. In fact, it's a point we already wrote above. But what is that point? What do we see here that clearly says, okay, you are right. There is this particular thing happening in the data set.
Here, data points are on different scales.
Yeah, that is the thing. So specifically now in the markdown cell, you can enter that. We observe that the feature pressure is at a different scale as compared to the other things. You can double click it. Put a hyphen. We observe that the feature pressure is at a scale very different from the rest. So now I'm just briefly telling it, but ideally you would frame it nicely because this is from a presentation point of view. It is not just for you, it is also for anybody who reads your notebook. Okay. So another thing is that actually if you see in this based on first look, there doesn't appear to be any outliers. So you can, in general, you can put that also. On the first look, there are no outliers. So
Balanced data set.
balanced data set. Huh? Is that what you suggested?
Yes, sir. Seems to be a balanced data set.
Okay. How do we say it is balanced? In what terms do we mean balanced? Are we talking about, in general, what is balance and imbalance associated with? Wait, don't add the last point. 1 second. Yeah. So in general, what is balance and imbalance associated with? How do we check whether a data set is balanced?
By outliers, sir, if they're
Okay, so when it comes to a data set being balanced or imbalanced, rather than outliers, it is associated with the target variable. So if your target variables, the classes that I take, in this particular case, the class is 0 and 1. If there is a difference in the counts, if there are, say, total in this particular data set, firstly, how many rows are there in this data set? We have not done that. How do I check how many rows are there?
shapes.
See,
Can you run that code?
Train.shape.
You can run train.shape directly. Yeah, now you'll see an error. What does the error read?
Brackets.
Yeah, brackets are not there, but ideally from now on you should read what the error says and try and understand. Okay. By the way, does the training dataset have only 2000 rows? Are you sure you have not read the test dataset? Can you scroll up once? Or scroll down a little. Yeah. Okay, this is fine, right? Yeah. Okay. All right. So let's go back down and continue. So as I was saying, imbalanced dataset happens now that there are 2000 rows. If it were the case that for class 0 there were only say 100 points and remaining all of them into class 1, then we say whether a dataset is balanced or imbalanced. So in the case of outliers, we just observe if there are outliers or not, and we make the statement as is. Either there are outliers or there are no outliers. And other methods to check for outliers, there are a few. So we can use those also next. But for this exercise, let us continue for now. Okay, there is another code snippet that has come up, which is info. So can you run that? Can you run train.info? Okay, can you add brackets to info? Okay. So what do we see from this? I want two observations. It is okay if it is a repeat of the previous, but based on this particular output, what are your observations?
No null values.
Perfect. So can you add that in the markdown cell? Perfect. So the first one is no null values. Second one is all features are of numeric type. Okay. Next, what code snippet?
Sir, xtrain dot rainfall and
Sorry?
value count. Xtrain
Okay.
rainfall.
Yeah, so you want to see the value counts, right? So can you run that? Can you run train? How do I select a specific feature?
Dot rainfall.
Okay, you can write train dot rainfall.
Train is square brackets, sir.
Yeah,
Rainfall.
both methods are fine. So for now, first run this one, rainfall dot value underscore counts. Dot value underscore counts. Put a bracket and run this. Okay, so now you see 1650 belong to class 1 and 540 class 0. This is where in general when we see we can comment whether or not the data set is balanced or imbalanced.
Imbalanced data.
Yeah, so here this is, yeah, there is a slight imbalance. It's like about 25%, 75%, but usually it is still okay. We can say there are enough data points. When it is under say 10% or even lesser, then we might have to look at other techniques also to handle this imbalance. So scrolling down, yeah.
So where this rainfall is defined, sir?
So rainfall is a target variable. It is a feature. So now we'll go for the other method. Instead of dot rainfall, you can put square brackets there. ERAIN square bracket. In quotes, you can put rainfall. And at the end, dot value counts. Okay. So the first part, train square bracket rainfall, is just the method to pick out a column from the data frame. And now usually you can again write a comment in Markdown that there are whatever percentage of values belonging to class 0 and remaining percentage belonging to class 1. Yes, Sudeep.
Sir, at what point we should think that it is not a balanced status?
Yeah, so as I was saying, in general 25-75 is still okay. It again depends on how many data points you have also. And if you end up having like say less than 10%, so if I have 1000 points belonging to one class and 9000 points belonging to the other class, then the imbalance is stronger there. So as you keep working on these data sets, you'll realize that if there is a class imbalance, certain models struggle a lot with that. So it can hamper your analysis. Your model will not be able to learn anything about the minority class. So in those cases, I think previously also I mentioned, you'll have to use things like for imbalance handling through something like SMOT, you'll do oversampling, undersampling, or you will set up class weights within the model. So those class weights are not the weights that we solved today, but these are saying how much should I weigh each sample. So this we have discussed previously. If not, you can again go back to the documentation and explore it. But in general, I would say there is no specific value as to say below this is imbalanced or below this is balanced. It depends from domain to domain. And like if you take the credit card fraud detection data set, what ends up happening is that there are very few frauds as compared to genuine transactions. Because in a day, you see that there are going to be millions and billions of normal transactions, out of which only a few of them will actually be fraudulent. In such cases, it will be under 1% or under 0.5% of the transactions being fraudulent. So that and all is a clearly imbalanced data set. Apart from that, as you work with these things, you try and you understand. Okay. Yeah. Coming back to this, you can say here, you can say there is 25%, roughly 25% points belonging to class 0, while the rest belonging to class 1. Something like that will be your comment. Okay. Now you can say something like the data set is slightly imbalanced, and you can also tell about what are the methods that you can use next. Like previously we wrote, there are no outliers in the data set. So there you can also mention subsequently, we are going to check further by using either say isolation forest or by using the based on sigma values we can check. So that way we can tell about what we are going to do next. So here here maybe after seeing this you can write things like the data set is slightly imbalanced, and if necessary we can use different techniques for it. And ideally you can mention those techniques as well. the data set is slightly imbalanced, and if necessary, we can use imbalance handling methods. Okay, so that's fine. Yeah, I hope you all got the idea. So what next? What can we do next?
Now, how to save the work?
Saving, is it? Saving happens automatically.
Oh, what is on the top? Save version 0.
That draft saved. So draft saved is just Kaggle itself automatically saving, and that save version is to take a proper snapshot. So ideally, when you finish your entire work, then you can click on save version. Can you actually click on save version now? Ravi, can you click on save version? The black button that is there on the right. Yeah. So here it says save and run all /commit. You can click on the drop down. Second below, version type, yeah. And you can click on quick save. So if you click, and now you can click on save.
Yes,
You don't need to give a name. You can directly click save. Okay, so now you can see it is saving it. So if you had clicked on run all and save, it basically runs all the code that is there in your notebook. It also takes the output and then saves it. Now this is just a snapshot. It is not going to run the code. It is just going to save it as it is. Okay. Sorry, your voice is breaking, Karthikeyan.
Next time when we open.
Yeah, so if your question is what happens when we open the next time, so it will be the recent most version. And the thing is now next to save version, even the number is 1. So what this allows you to do is you can go between different versions. Okay, so you can click and explore it later. But when you click on it, it will show the different versions, and yeah, you can just click the back button to go back to the code. But say normally when you're working on your project, you might end up having 50 to 100 versions and so on. Every time you run when you save your model, when you make submissions to a competition, it makes a new version. Yeah, so you can navigate between those different versions by saving it like this. And every time you open, it is going to go to the recent most version. And by choice, you can switch between things. Okay.
And one last question. This help function and all will work in this because
it will work on this as well. So these are all based on Jupyter Notebook. So you can use help.
Autofill and those things will work.
Autofill is not there. So autofill is something that is there in Colab. So for this, maybe if you put some extensions, it might be there. Some small autofill is there. I mean, the GenAI part is not there. The other autofill is supposed to be there, but sometimes it tends to be a bit slow, especially when you're doing imports and all that. It might not come quickly. Okay. So those are things about the platform that you try out a notebook on your own and code. That time you'll get familiar with this environment. That is the best way to understand those things. Okay, so next, I think we are running out of time as well. So let's do some more. One of the things I think multiple of you have brought up is how similar two features are. So for that, what should I do? What is the statistical measure that finds out how similar features are? What should I run for it? Correlation, right? So can you run train.corr, train.corr and bracket? Yeah, can you run it? Okay, so now it gives the correlation values. But once again, as we have been discussing today, it's not just about writing the code, it's about how we present these things and communicate. And with correlation, generally sort of the thing that people like the most is to present it as heat map. So can you go to a new code cell? So for heat map, we are going to import two libraries. First one will be import matplotlib.pyplot_splt. Matplotlib continuously .pyplot pyplot as PLT, and the next is import Seaborn as SNS. Yeah, run this cell. Yeah. Can you go to the next code cell? So you can write SNS.heatmap. in the bracket, write train.corr. Yeah, see the error message says requires one positional argument, which is the data. So which is what we are passing now, train.corr, and again it should be corr bracket inside. Okay, run this. Okay, so now we have got a heat map, but it does not have numbers. So the next upgrade that we are going to do is we are going to add numbers. So next to the
And
corr bracket, yes,
N naught is equal to true.
correct. So you are going to put n naught is equal to true. So next to corr, there is the same code cell. After the bracket, put a comma, not inside. Go right, one right. Yeah, there put a comma, write ANNOT. This stands for annotations, and you can write equal to true. Yeah, can you run it? Okay, so this is because it is not running the whole thing properly. So ideally I wanted to show something else. Can you go to one cell above, as in one line? Okay, it's finally here. So now you can see what is the problem with this.
Size is
Distance.
figure size. Is
Sorry? Yeah, so the size is not good, right? So go one line above where you have written this code. In the same cell, where you've written sns.heatmap, go to a line above. No, you can go to the front of that line. Just before SNSDS, you press and enter. No, the cell below, where you run your heat map.
Here.
Enter before SNS.
The cell below, yeah. You can press and enter before SNS. You have done sns.heatmap, right? Yes. Okay. Now in the line above, you can write plt.figure. And put brackets. Here you write fig size, FIG, SIZE, equal to, in the bracket, you can put 12,12. And now below the sns.heatmap line, do plt.show. Brackets and run. Okay.
Yes,
Scroll
sir.
down. Is this better? Now, if you read the heat map, it shows correlation between 1 and -1. The ones that are dark black, so you can see -0.81. So that is the negative correlation between sunshine and cloud. Okay.
In last line of code, why we required plt.show? Earlier it was showing.
Yeah, so because when we did plt.figure, we have now used matplotlib to start displaying these this ones. Previously, we were using just Seaborn. Seaborn had a way to present it. Of
Okay,
course, there are multiple different methods. Yeah.
Seaborn need to type dot show, right?
No, you don't need to. So even with matplotlib also, it's not always mandatory. So it works in different ways. These packages have certain ways in which they work. I think in the last session we also did it with those tree plotting images. So when you use matplotlib, now your whatever Seaborn is producing it, we are going to make use of matplotlib to show it as a better image. So we have increased the size based on that. So it is just some simple combination. You can look it up, different ways to do these presentations, whichever suits your fancy, whichever is comfortable. In dark black are those with strong negative correlation, and the ones that are more towards white. So for example, cloud and rainfall have a strong positive correlation. Can you see 0.64? Can you highlight that? Yeah, links. Yeah, so cloud and rainfall seems to have a strong positive correlation, and sunshine and rainfall seem to have a strong negative correlation. So with this, we roughly get an idea that, okay, if there is cloud, there is a good chance of rainfall. Likewise, if there is sunshine, there is a lower chance of rainfall. So this correlation has sort of brought about this hypothesis. Now, as we build the model, it may or may not turn out to be important, but from the data, we see this. So ideally, after this correlation, now in the markdown cell, you can enter all these sort of things that you have found out from it. Okay, whatever has strong positive correlation, whatever has negative correlation, all those things. Okay, so and you roughly got the idea, right? So now what we have been doing so far is we are still exploring our data. So all this will come in the part of EDA, exploratory data analysis. So you can do a lot more things here. You can do box plots, and you can correlation is one thing we checked. You can do scatter plots. You can check pairwise scatter plots. You can tell which features influence each other. Distributions about all features. What are their outlier analysis using different methods. If there were missing values, some data on the missing values. All these many things you can do as a part of EDA. Okay. So once you do your EDA, the next part will come something like feature engineering and data pre-processing, where you might actually, you have done some of these things as a part of your OPP, right? Handling missing values, encoding them. In the case of feature engineering, you can even do things like extracting new features, creating new features, cleaning up the features. If there is text working with that, all those things will come in feature engineering. After that comes your model building. So in model building, you can do your train test set, you can try out simple models, you can do hyperparameter tuning, and then you can get to analysis, where you do your evaluation metrics. You're going to see your confusion metrics display, your classification report, analyze them, and then again repeat the whole process from the beginning. Iteratively, you are going to keep improving. You are going to keep tweaking things, and it's a bit like cooking. You might learn one recipe that, first do this, then this, then this, then this. You are going to get some product. But then some other professional chef might say, okay, this is okay, but it is not that great. And then you start experimenting. You tweak things a little bit here and there, and you keep seeing how it changes. Sometimes the result might be as you expected, it might be good. Sometimes it might not be that great. So this entire process of building a pipeline is iteratively you keep improving. And as you do more and more of this, you start getting better. Okay, so this is the overall picture. And in the interest of time, I'm going to close this here. This is why I gave the rough idea of what you'll be doing next. And yeah, so in the
how to submit this, say we are coding this.
Yeah, so for submission, that is where that sample submission and all comes. So what you'll have to end up doing is whatever steps you do, the whole thing, you're going to have to run it on the test data as well, because that's what we do, right? We do the transformation, we do the fitting and all on the training data. And whatever we learn, we just use the transform and the predict methods on the test data. So once you make your test prediction, it is going to ask it in specific format. That is in the format of the sample submission. So you're going to end up creating a file called as sample submission as a CSV file. And in that sample submission, you might have two features, an ID and your prediction. So it depends on what this particular competition asks. Can you actually go back to the competition page? Can you click on that right arrow in the right corner bottom, the one that we closed before, right bottom corner? Yeah. So if you come down, scroll down. Yeah. So there is submit to competition option. Yeah. Click on the binary prediction button, not the submit button. The binary prediction button. Yeah. So now can you go down to, yeah, just go down a little. Yeah, go down. Yeah, so here, stop here. So here you can see the submissions are evaluated on area under ROC. So that is also an evaluation metric. And this is the submission file format that is desired. ID will be one column and rainfall is the other column. And in the rainfall column, they don't want 0 and 1. They want your predictions. So they want you to give probability. So for which you will use something like the predict proba method. So this will be your submission file. So the test data might have, say, some 1000 rows, for example. So once you train your model, you are going to use, say, if my model is called, say, CLF, then I'm going to do CLF.predict on the test data, and I'm going to get some values. And since I need probability, I'll do CLF.predict proba. I'm going to get those 1000 values. I'm going to put them in a data frame with one column called ID with the ID values and another column called rainfall with the prediction values, the probability values. And then this is going to be submitted as a CSV. For that, there is a code snippet. If you guys are interested, whenever you can ask it, you can try this out on your own. You can even Google how to make submissions on this. Actually, can you go to code? Can you click on the code tab next to data? So scroll down and can you click on hotness? There is one, go up. The first part of this. Scroll up a little. Yeah. Go further to the top here. Yeah, so there is a hotness on the rightmost. Keep going right there, right here. Can you click on most votes? Okay, so these are your top models. Can you scroll down a little? It's not fully loading. There are some of these guys who make very nice notebooks. There might be a lot of things in this you don't get, but each of these notebooks at the end will have the simple code for submission. So if you don't get, you can even look it up there. If not, you can put up a post on Discourse and you can tag me. I can help you. I can click on, scroll up a little. Yeah, hold it there. So there is this photo of a guy with a tie, right? Scroll down. Scroll down further. Yeah, this one. Playground S5 V3 baseline V2. Yeah, can you click on that? So usually his notebooks tend to be quite good, but it might have a lot of things that you don't get. Can you scroll to the very bottom? Yeah, scroll a little up now. A little bit. Keep going a little up until you come to the code part. Up. Okay, it is still loading. So there is one submission. Can you scroll down table of contents on the right side? Yeah, scroll down there. Click on submission. Yeah, click on it. Okay, I guess it's loading. Scroll up a little. Yeah. There was that code, right? Yeah, scroll down a little. Okay, so he has done it in a little different way, but usually you will get a simple code for it. Basically, you want the submission file to have two columns. You'll have your ID and your predictions, and then you'll have it as a CSV. Then when you click the submit button, it will work. Like I said, if you guys are interested, you can even drop a mail to me. You can tell me if you're interested. I can assist you with writing a basic code and making a submission to this competition. I hope you guys have my email. If not, I'll just share it in the chat. Yeah, you can stop sharing your screen, Ravi. Thank you very much for sharing and helping us in.
Thank you so much, sir.
Yeah, if you guys want to work on these data sets, if you're interested, if you want a basic setup of this, you can let me know. You can drop a mail. I can help you. Yes, Bhavana, please go ahead.
Sir, in MLP project, we did doing these similar thing.
Yeah, in the NLP project, general idea. So, which is why right now itself, if you start getting familiar with this, your experience with the project is going to be much better, and you'll also be able to do much better work. See, the key is not just writing code. Of course, like I said, you're going to be iteratively writing a lot of code. You're going to be trying out many different things. But it's not just about writing code. It's about providing your analysis and thought process behind the same. Okay.
So we work on the competition.
It will not be any random competition. It will be set up from our side. We are going to be giving a problem statement, a data set, everything. And then you are going to be working on your data set. It is going to be on Kaggle itself. And of course, when you start the project, you will know about it. The thing that you can try is to work on some competitions that are already present as playground competitions. And that should help you get started easily. Okay?
No, sir, I took in next term. That's why I'm.
That is absolutely fine. So, like I said, since it's next term, use this term break and try out a few playground competitions on Kaggle. And during the project also, you're going to be having support from our side. wherein we are going to walk you through some submissions, how to set up your account and everything that is there. Okay. For now, you just focus on working on these skills. Yeah. So just one last thing. So if you guys have any questions, you can stay. If not, like I said, I'll not be covering anything else. So for all of you guys, thank you for joining. And if you have any queries regarding this, you can please feel free to stay back.
I just requested for this OP